Hello guys, welcome back to my channel. So we ended the last video on the topic angles between the vectors. So I would just give you a quick revision of about what angles between vectors means. So angle between vectors, we always consider the smaller angle between the two vectors at the tail to tail contact. So this was the basic example we did. I will solve another example for you to make this even more clear. For example, if you are given a question like this, these are the two vectors and they have an angle of 120 here, and the question is asking what is the angle between these two vectors. Okay. So what do you think the answer would be? Is it like the answer would be what do you think the answer would be, 120 degree or what? No, the answer is not 120 degrees, because we should go back to this definition, and it said tail to tail contact. So according to the question, is this a tail to tail contact? No, it is not a tail to tail contact. So I have to use my laws or properties of vectors, and I'm going to make it convert into a diagram in which it represents a tail to tail contact. So what I'm going to do, I will shift this vector parallelly here. So my next diagram, what it turned out to be this. Now is this a tail to tail contact? Yes, it is a tail to tail contact. Now using a basic mathematics, can you tell me what angle this can be? Yes, this angle, if this is 120 and this total is going to be 180, so this will be 60. So our angle between these two vectors would be 60 degree and not 120 degree. So, let me solve another example for you. For example, we have given a question this, and the question gives that it is 45 degree between these two vectors. Now the question is asking theta, that is the angle between these two vectors. What do you think the answer is gonna be? Is it gonna be 45 degree? Yeah, maybe yes, maybe no. What can we do? Let me shift the both of these vectors parallelly. I'm gonna shift this vector here, and I will shift this vector, the horizontal vector, here. So my next diagram would be this. Now tell me, using a basic questions of basic rules of mathematics ki, what this angle would be. If this is 45, by alternating angles this is going to be 45 too. So our angle between these two vectors, that is the value of a theta, is 45 degrees. Okay, so now what was the sense of doing this? Now we have done the basic, how to represent a vector, what is the angle between two vectors. Now where the actual questions comes in is vector addition. Now this is a really important topic for you, because you will straight away get a question from vector addition. Now what does vector addition mean? Simply it is a process of adding two or more vectors, and the resultant vector, means the addition of the two vectors will result into formation of a resultant vector, which by definition wise, though it is not important for you at all, this might help you in your 11th class final exams, theoretical exams, but it's not is any use to you in the final NEET exam. But still I would say out the definition for you all once. It is that vector which can produce the same effect as all the vectors of combination can produce together. Means if there's a box and I'm putting up four forces on it, this, now what these four forces are gonna produce the effect, my resultant vector will individually produce the same effect. So this is a resultant vector, and by vector addition we are always gonna find out a resultant vector of two or more vectors. Okay, now as I said, we vectors don't follow the normal basic mathematical algebraic rules. So we have this vector algebra different from that of a mathematical algebra. So we also have different laws for the vector algebra. So the first law is the triangle law of vector addition. What does the triangle law say? If two sides of a triangle represent two vectors in same order, then the third side of the triangle represents their resultant vector in opposite order. What do I say? I will draw another diagram for you here. Once again I'll repeat the definition. If two sides of a triangle, first of all let me make a triangle. Okay, this is a normal triangle. Geometrically I don't know, it is an equilateral triangle, whatever triangle it is. This definition says if two sides, means let me consider this side and this side. If two sides of a triangle represents two vectors in the same order, means if I'm going in let's just say anti-clockwise direction, so I'm going in anti-clockwise direction. So this is my vector 1, let me name as vector A. Okay, and in anti-clockwise direction, this is gonna be my vector B. Now these are my two vectors and I want to add these two vectors. What is my resultant gonna be? The definition says if two sides of a triangle represents two vectors in the same order, then the third side of the triangle represents the resultant vector. So the third side represents the resultant vector in the opposite order. So this is going to be the opposite order, which is going to represent the resultant vector. So A vector, B vector, and the resultant is this. I draw the resultant in the clockwise direction because the definition says opposite order. Okay, the same diagram I've drawn here more in the fair way. This is vector A, this is vector B, and the R represents the resultant vector. Graphically, or like with symbols, I can simply write R vector is equals to A vector plus B vector. Okay, now there are few examples that I've solved for you. I've already solved, but I will solve them again so that you can easily get it. This is just for the fair work or for your notes, if you can easily get it. The green ones represent the two vectors we have been given in the question. The first one says this is vector A and this is vector B. Now we said both the vectors should be in the same order, tail to head, tail to head. Both of these are in the same order. The resultant vector would be in the opposite order, that is from first tail. Now this was going in clockwise direction, so I will draw the resultant vector in the anti-clockwise direction. So this is my resultant vector. Now you are given two vectors here, A vector and B vector. I have to draw the resultant. Now I said same order. Let's just say we are saying I am drawing, how am I gonna actually join these two vectors? If you will notice, same vector same order means now I am joining the head of the first one to the tail of the second one. That represents the same order. So I wanna join whatever you wanna do. This is A vector, this is B vector. Okay, I'll do it both ways for you. I'm gonna join head of B vector to tail of A vector. How am I gonna do this? I will shift A vector parallelly from this position to this position. So my vector would be like this and this. Now this is my B vector and this is my A vector. I said, now if you can see, this is in clockwise direction. So my resultant vector will close the triangle, but it will be in the opposite direction, that is this direction. So it will be from B, at the connection point of B, it will be the tail end, and this is going to be the head end. So this is my resultant vector. If you want to do, no ma'am, I am going to join tail of B with the head of A, okay, you do that way. So I'll shift B vector over here. So this is A vector, and next I'm gonna shift B vector parallelly horizontally upwards. So this is gonna be my B vector. Now since this is in clockwise direction, the closing triangle we are doing from A to B. So the closing angle would be this in the anti-clockwise direction. So this is my resultant vector. Now can you tell me, is the resultant first vector equal to resultant second vector? Yes, they both are equal because they are parallel and they are exactly same in the magnitude. If I would have drawn it with a scale with equal measurements, they would have been of exactly same length. So here I did a B vector plus A vector, that is equals to resultant vector, and here I did A vector plus B vector, that is equals to resultant vector. So both of these are same. So I have solved two more examples for you. These are simple examples. Question was given to you. This is A vector and this is B vector. Am I gonna simply turn complete the triangle and say that is the resultant vector? No, I'm not gonna say, because just now I said I have to connect first vectors head end to second vectors tail end. So I will first shift B towards the left, and this is gonna be my final diagram and triangle. And now I'm gonna close this triangle from here to here. Now my vectors A and B were in the anti-clockwise direction, so my resultant vector will be in the clockwise direction. So my answer would be this. This is my resultant vector. Sorry, I made a mistake. This is not going to be my resultant vector. This is in anti-clockwise direction, so I have to make my resultant to the clockwise direction. So this is going to be my resultant vector. I'm going to solve another example for you. Here we have given these two vectors, A vector and B vector, and they are asking what is the resultant vector. So tell me, am I going to close the triangle directly? No, I won't close the triangle directly. I will first draw join the head end of a vector to tail end of b vector. So I'm going to shift b parallelly downwards. So this is my a vector, this is my b vector, and now I'm going to join these two vectors, and this is going to be my resultant vector. How, where I'm going to put the arrowhead, if you can look, this is in anti-clockwise direction, so my resultant would be in the clockwise direction, means this is the tail end and this is going to be the head end. So this is my resultant vector. Okay, simple as that. Now diagrammatically done, okay, ho gaya. But we have to solve numericals basically. So to solve the numericals we need to do a analytical method. Now analytical method, what does that mean? Analytical method is you will be given two vectors, you will be given their magnitudes, their directions, the angle between these two vectors, and they will ask what is the resultant vector between these two. Okay, now let me tell you one thing. This what we did in every question where we solved, if I said ki a force, for example there's this box, okay, simple as that, because everyone can imagine force happening in front of them, so it is easy to explain things with the help of force. So this is a box kept in front of me, and it is suppose 10 kg box. I am putting one force over here, that is of 5 Newton. Okay, you might not know the unit of force is Newton, but we'll come back to force in later chapters. But right now let's just consider that this is a 5 unit force being applied in this direction, and there's this another force that is being applied to this box in this direction, that's a 10 unit force, and the box is in air. There is a possibility of the box moving in this direction. Okay, so what am I gonna do you think that this box, where do you think is this box gonna move technically? Let's just consider 2-3 possibilities that this box, this 10 kg box, this 10 kg box moved from its initial position here to the final position here. What does that mean? That this box, this force didn't matter to the box, but it didn't happen this way. Both the force are being have to be considered. Resultant means the addition of these two force. Now let's just say I said okay, the box didn't move in this direction, but the box moved downward 10 kgs over 10 kgs over here. Did this happen? No. I said I want a resultant of the two forces. So what the box is exactly gonna move? The box will move exactly over here. Means in between these two vectors, the resultant of A and B will always be in between A and B. Okay. So if I draw, if in graphically, if you want to see too, now if I said this is A vector and this is B vector, and this as always is the resultant, this one as always is the resultant in the opposite direction. If I rearrange this whole setup, okay, now let me shift this B vector to this direction parallelly. So my resultant diagram would be, this is my A vector, this is my B vector that I shifted, and my resultant is where it already was, I didn't shift it. So this is my resultant vector. What are you observing? We observed that if I join those two vectors that we were adding by the tail to tail contact, the resultant vector lies exactly in between these two. Okay, so it is never gonna be like this, that the resultant lies here. A vector is here, B vector is here, and the resultant is somewhere outside these A2 vectors. This is not gonna happen. The resultant will it will be here. If A is of greater magnitude, it will be here. If B is of greater magnitude, or it will be in the center of these two if both of them have equal magnitudes, but it will never be outside A and B's tail to tail contact. So that brings us to the analytical method of vector addition. Now analytical means that we are doing calculations. I represented it graphically. Okay, this is A vector, this is B vector, this is resultant vector. We are not giving a theoretical exam. We want the magnitude of the resultant vector, the angle of this resultant vector to A vector, the angle of this resultant vector to B vector. We want everything. Okay, so how am I going to solve this? So this is my basic diagram. This is my A vector. This given this is my A vector. this is my b vector over here, and the resultant vector is going to be somewhere in between these two. So this is my resultant vector. Okay, so now I want to find out the angle between the result magnitude of how I'm going to proceed basically. So what I did here is I shifted this b vector from this position horizontally towards the right, and I bring it over here. Okay, exactly what we were doing, tail to head, tail to head, and this in the opposite direction. From tail to head is the resultant vector. This is my resultant vector. Now I'm gonna extend this line. Okay, I'm not extending the vector, that would change the vector magnitude of the vector. I'm just extending, making a dotted line over in the horizontal direction. I'm making another dotted line, drawing a perpendicular over this horizontal line. So this angle is 90 degree because I drew a perpendicular. Okay, now this is, if this whole angle between a and b is theta, by laws of parallel lines we can say this angle is theta 2. Okay, now let me consider this little, one second, let me consider this little triangle, this triangle BPM, or B is the vector, let's just name it QPM. I made it here in the side. This is my triangle QPM. Now we have to use a basic maths rule. We know sine theta is perpendicular upon hypotenuse. My perpendicular here is, I just didn't give it any value, I just said perpendicular, and my hypotenuse, that is this, is the magnitude of B vector, that is B. So my what does the value of my perpendicular came in? My perpendicular would, that is my MQ is equals to B into sine theta. Similarly, I do this for cos theta. Cos theta is base into hypotenuse. Now my base is MP and my hypotenuse is B. So my value of my MP is B cos theta. Okay, now I'll come back to this another triangle, that is I would just skip this B and P line. I won't draw this, and I will draw a triangle that is QOM. Okay, I do QOM, in which MQ I will put up from here, M value of MQ, that is B sine theta, and this OM is can be divided into OP and PM. Okay, now I can put the value of MP PM from here, that is B cos theta. And what does OP represent? OP represents the magnitude of A vector, that is A. So I can say OM is equals to A plus B cos theta. Okay, now in this triangle I said this is the angle alpha. What is angle alpha exactly? Angle alpha is the angle between the resultant vector and A vector. Between these two we have the angle alpha. We can say, what does tan alpha means? Tan alpha is equals to M upon, okay, let's just we'll come back to this later. Okay, first let me give you the magnitude of R vector. How we are going to proceed to the magnitude of R vector? Now I considered this QM triangle. In this QM triangle I'm going to put that basic theorem, that is hypotenuse is equals to perpendicular square plus base square का whole under root. This is what I have done. Simply if I'll square both the sides, it will be hypotenuse square is equals to perpendicular square plus base square. That's the basic mathematics, you know. So in this QOM triangle, hypotenuse is OQ, base is OM, and our perpendicular is MQ. So we squared it all side. OM I can divide it into two parts, that is OP plus PM. I just said OP is equals to A, PM, let's just, for example, I've written just PM equals to PM, either MQ is equals to MQ. Now we solved all of this, and I have put in the values of, from here I am coming directly here because I showed this PM is equals to B cos theta, MQ is equals to B sin theta. So my R square is equals to A plus B cos theta plus B sin theta whole square. I'm going to open this with the simple definition. A plus B whole square is equals to A square plus B square plus 2AB. We know that. So what does A square? It will simply come to A square. B square would be B square cos square theta plus 2 times A into B cos theta, and B sin theta would be B square sin square theta. Okay, from this point and from this I can take B square common. So I took B square common, so cos square theta plus sin square theta came into bracket. Now we know this from this rules of trigonometry, that sine square theta plus cos square theta is equals to 1. So this got ruled out. Okay, b square into 1 would be b square. So our resultant vector simply came as a square plus b square plus 2ab cos theta whole under root. Now this is a formula that is going to save your life, that is going to be so important for you for solve all the numericals in the future. So you have to remember this formula. Now until now, this is the very first formula that is of importance for you to solve the questions. So what I am gonna tell you is make a formula copy for yourself and write down all the formulas that I ask you to do. And every day after you finish your studies, you have to open up your formula copy and start reading and revising all your formulas from the very beginning. Okay, so this is gonna be the first formula that you're gonna copy in your notes book, and along with that you're gonna draw this diagram in your notes copy, that this is the a vector, this is the b vector, and this is the resultant vector r vector, and you will draw you will draw angle theta, and you will draw two more angles, that is angle alpha and that is angle beta. And I'm going to further tell you two more formulas that you have to write in your formula copy today. Okay, so till now I'm sure it is all clear. If something you have doubt in something, you can definitely tell me in the comment box and I will clear all your doubts. Now I will come back to my rough diagram that I drawn up above. So here let's come back to tan alpha. In this triangle OQM will come to tan alpha. What does tan alpha means? Tan alpha is perpendicular upon base. My perpendicular is MQ, that is B sin theta. My base is OM, that is A plus B cos theta. So my this angle alpha, tan alpha is MQ upon OM, that is B sin theta upon A. Now if we'll have the value of tan alpha, we can give the value of alpha. So this is my second formula that you are going to copy in your notes book, and that is this formula, that value of, let me just tell you, this is the second formula that you're going to copy in your notes, that is tan alpha is equals to b sin theta upon a plus b cos theta. Okay, this is the second formula that will give you an angle of alpha. Now we'll say, ma'am, how are we gonna give the angle of beta? Simple. If you have angle theta and you have angle alpha, you can simply calculate beta as well. But if you want a formula for angle beta, if I repeat the same procedure in the opposite side, that is I would have shifted this vector a over here, then I would have extended this line, and then I would have drawn a perpendicular from here, then I would solve the whole diagram in the opposite direction, then we would have gotten a formula for value of resultant would have came exactly the same, but the formula for beta, that is tan beta, would have come to, that would have been tan beta, I will write it in black for you all, tan beta would have been a sin theta plus b plus a cos theta. What I did, I just turned all my a's into b's and b's into a. Simple as that. Okay, now what you have to do is you have to write all these three formulas, but what do you have to remember exactly? Don't try to mug all the three formulas. Use your basic common sense, learn tan alpha, and ever if you get a question on tan beta, either you can simply give theta minus alpha is equals to beta, you can solve that way, or you can just simply write formula of tan alpha and then shift all my b's into a's and all my a's into b's. Simple as that. You don't have to mug up three formulas. So by now you know in total of three formulas, but you have learned in total of two formulas that you are gonna write in your formula copy along with this diagram. Okay, till now we are done with this. Now I am giving you three more cases. Okay, this is like, most commonly asked questions. If this is the angle, so you will simply just go for shortcuts and you can do this. So my case one would be if both the vectors have an angle of 0 between these two. So my value of I'm gonna put the values in the question. So my cos theta is equals to 1. So this will simply be a square plus b square plus 2 ab whole under root. This is actually the formula of a plus b whole square. So my resultant would be r vector would be r is equals to a plus b. This is the maximum magnitude. Case 2 would simply be if the angles are in exact, means if the vectors are exactly opposite to each other, that is have an angle of 180 between both of these. So my resultant vector, I would put the value of minus 1, minus 180 is the cos 180 is minus 1, so I put it here. So this will come as a minus b whole square ka under root. So my r will be a minus b. Now case 3 would be if both of these are exactly perpendicular to each other, that is having an angle 90 between both of these. So cos 90 is 0. So my value 0 multiplied by anything is always 0. So my resultant would be a square plus b square whole under root, which is not going to be solved directly. We have to put up magnitudes to solve it. Now how can I say a minus b is minimum and a plus b is minimum? Because every other time you will get some value. How is a minus b minimum? Because every other time there will be some value here. What is the maximum value of cos? Let me just ask. It is plus 1. What is the minimum value of cos? Minus 1. So if I will put in the formula the maximum value of cos, I will get the maximum resultant. If I put the minimum value of cos, I will get the minimum resultant. So a minus b would be my minimum and a plus b would be maximum. Every other magnitude will always lie in between these two. So are you gonna write all of these in your note copy? You can simply just write this formula, means I'm giving you side by side, I'm telling you how you have to make your formula copy as well. So here in the side I'm telling you what are you going to write in your formula copy. You will write after those three formulas, you will just write special cases, and you'll write a minus b r a plus b. You point out this and you will say theta is equals to 180 degree. Here you will say theta is equals to 0 degree, and you and here you will mark a star and you will, when theta is equals to 90 degree, resultant is equals to a square plus b square. Okay, you will write this much in your notes copy. Are you gonna mug up this much in every time? No, you won't mug up. Every time you look at it, and this is gonna give you a clarity that okay, you have to work up like this, you have to always put up theta angle and all of this. Just in case, if you look at things 10-20 times, you will remember things, and once you remember, if you will just click upon you, like you saw that the angle between these two actors is 0, oh, I have to just add up it together and it's going to be a plus b. So you'll write it, but you won't mug up. The only thing that you have to mug up is this formula, because you can't solve the whole process every time. So this formula you will definitely mug up. You will mug up this tan alpha, you will write tan beta as well, and you will write these special cases as well. So I think enough for today. In the next lecture I will try to solve few questions for you, so this is going to be much more easier and more clearer to you. You can ask any doubts in the comment box, whatever you have any doubts, or you can even ask questions. I'll try to solve them as much as possible. So thank you so much for today's video.